Hey everyone, hope you're doing well today. In this video, let's take a look at a half-life example problem together. In this example, a certain medicine has a half-life of 5 hours. If a patient is given 500 milligrams at noon, the question is, at what time will they have 100 milligrams of this medicine remaining in their bloodstream? Just so we're on the same page, this is the formula we can use to solve half-life problems. A represents the amount of a substance at a given time. A naught or A sub 0 represents the starting amount of some substance. T represents time, and finally H represents the half-life of a substance or the amount of time it takes for the substance to be cut in half. Let's see what we're working with for this problem. We're given in the problem that A is equal to 100 milligrams and A naught is equal to 500 milligrams, so we know the amount left and the original amount. The question is asking us about time, so we don't know the value of T right now. However, we are told that the medicine has a half-life of 5 hours, so we know that the value of H is equal to 5. It looks like we know 3 out of the 4 variables, so we can use that information to solve for T, or time. Alrighty, here's a little bit more space to work with. So now that we've identified the formula we're going to use, as well as the variables that we know and don't know, let's get into solving the problem. To start, let's just go ahead and write the formula of A is equal to A naught times the quantity of 1/2 raised to the T over H power. Then, substituting in the values that we know, we can write that 100 is equal to 500 times 1/2 raised to the T over 5 power. Since we're solving for T, let's try to get rid of as many things from the same side as T as possible. To begin doing that, let's divide both sides by 500. These 500s will cancel out on the right side, and on the left side we'll be left with 1 over 5. Rewriting this, we have 1/5 is equal to 1/2 raised to the T over 5 power. To solve for the value of T, we're going to somehow need to get that down from being an exponent. The trick in getting that variable down from the exponent is that we're going to use logarithms. Specifically, we're going to take log base 1/2 of both sides of the equation here. Why are we taking log base 1/2? Well, the base of the exponent, or the base of the power, is 1/2, so we got to take log base 1/2 to cancel that out. Once we have the logarithm written, it's important to know that one of the properties of logs is that we can take the exponent and rewrite it in front of the log instead. Basically, since we took log base 1/2 of both sides, we could then use the property of logs to take that value of T and bring it down so it's not an exponent anymore. Rewriting this, on the left side we still have log base 1/2 of 1/5, and on the right side we have T over 5 multiplied by log base 1/2 of 1/2. Remember, log base 1/2 of 1/2 is just equal to 1, so we can simplify this even more. From this, we're going to get log base 1/2 of 1/5 is equal to T over 5 multiplied by 1. And by the identity property, we can go ahead and drop that 1. But next, we're going to multiply both sides by 5 so that we can get T isolated. The 5s are going to cross cancel on the right side of the equation, so we're going to be left with T is equal to 5 times log base 1/2 of 1/5. This right here would be the exact value for T. Now, to find the approximation, we're going to have to put this into a calculator. To plug this into a calculator, keep in mind that many of them won't be able to use base 1/2, rather they only use base 10. Rewriting this into something more friendly we can put into a calculator, we can say that T is equal to 5 times log of 1/5 over log of 1/2. Essentially, we just rewrote the log expression into base 10 because that's easier to put into a calculator. The value of log base 1/2 of 1/5 is going to be the same thing as log base 10 of 1/5 divided by log base 10 of 1/2. Remember, we have invisible bases of 10 when we don't see them for logs. Plugging this into a calculator, we find out that T is approximately 11.61 hours. To understand this 0.61 hours, or 61/100ths of an hour, keep in mind that that's about 61% of an hour, or 61% of 60 minutes, which is essentially about 37 minutes. In terms of hours and minutes, T is approximately 11 hours and 37 minutes. So in summary, the medicine that was given to the patient